Hello, my name is also John with my colleague Chipal Derek. Here we have our slides for explainable AI, basically for our project. Our project it's entitled Contrastive Noise Distillation for seed variety classification, and we are using capsule network and attention mechanism. So a person should be asking like, what's explainable AI? So explainable AI is basically a technique which makes the decision process for learning models transparent and understandable to human beings. And so the moment you happen to look at machine learning or the projects that we're developing, so our projects are kind of not like a layman, a person that doesn't know about AI cannot be positioned to tell. So with explainable AI techniques, we can make this process understandable by human beings, and you can be asking why explainable AI. That may happen to look at the models or the entire project that we happen to develop to a layman, a person that doesn't have knowledge of machine learning. It's like a black box. So with expandable AI, it helps him to understand more about the entire project. Another reason, another reason why expandable AI, and so with expandable AI, it enables or it enables a human to understand why models make a particular decision. So with this, it increases trustworthy, helps to identify bias or errors, and it supports model debugging and improvement. So on the next slide, we have expandable AI in classification tasks. So what's the goal that we are trying to aim at? To visualize the regions that the model here we are trying to visualize the regions that the model focuses on when making a decision. So it compares interpretability across the best theory and the worst two performing models. Yeah, so with expandable AI, it helps you to compare between your theory and the worst performing models. So the method or the techniques that we used in our expandable AI classification task. So we use the grand cam, we use the silence maps and the sharp values. So and we happen to perform our expandable AI on 5 models, and these are the distinct mobile net model, which has an overall accuracy of 98.3%. We also performed the expandable AI on a distilled vision net model. We also performed it on the VIT model, and we performed it on the KD sparse CNN model, which has accuracy of 65%. So the visualization of the grand cam basically a technique that we used when doing the expandable AI. So we visualize parts of an image, visualizes which parts of the image that are most important for the CNN to make specific prediction by using gradients of classification score with respect to the final convolutional feature map. So the process we happen to go through when applying the grand cam, identify the final convolutional layer, so calculate the gradients, weight feature maps, and create heat map. Yeah, so I think that's all for me. Let me call in my colleague to take you through the next slides.
Okay, my name is Paul Derek. So on the next slide, we are continuing with the visualizations. So on our next slide, we are continuing visualizations. So my name is Paul Derek. So the first visual we have is for Grand Cam. The first visualization is the Grand Cam for distributed mobile net model. So with this Grand Cam output, we can observe some different features. For example, we have red and yellow colors. We have red and yellow color regions, and then we have some sort of green and blue colors. So red and yellow colors with Grand Cam, it indicates the region is where the model concentrated, like where the region is that the model used for decision making. So with this visual, we can observe that the model concentrated on regions with our GNAT seeds to make decisions, and the regions with blue and the green color and regions with blue and green colors like were lesser significant for models prediction decisions. Then on the next slide, it's the Grand Cam for distributed vision net model. So with this output of Grand Cam for distributed vision net model, on left we have the original image, and on the right we have the Grand Cam visualization output. So we can observe from the Grand Cam output visualization that still the region, like we can observe red and yellow color concentrated on the regions containing groundnut seeds, and the blue color surrounding and the blue color from other region, like in other region. So here, as I said earlier in the previous slide, we can conclude that the model much concentrated on regions with GNAT seeds to make classification decision, because I mentioned earlier that here the model majorly red and yellow colors majorly indicates where the model is concentrating for its decision making. Then on the next slide we are continuing visualizations. So we have the salience maps technique. So with this technique, for it computes the gradient of the output with respect to input pixels, and then it shows which pixels the model is most sensitive to. And with the salience map strength, with strength, salience maps fine gained pixel level visualization. I mean, with strength, it uses fine gained pixel level visualizations. So this is the salience maps for semantic computational network model. So in this output, we can observe an original image besides a salience map output. So for it here, we can observe the pixel the model is most sensitive to, and we can see in these red colors on our output. We can observe red colors. We observe the heat map dominated by vibrant red color, which indicates the areas of highest salience, and primarily we can conclude that the model concentrated on the guineas themselves, as we can observe from this output. And then it's the same story with science maps for node distillation sparse convolution neural network, as we can observe here. On the left is the original image, and then on the right is the science map output, and we can observe that, and we can observe the vibrant red colors, you can, as we can see here. So which indicates that the model also concentrated on the guineas, like the model, which indicates that the model concentrated on the regions of guineas to make decisions, like classification decisions. Then on the next slide, I have visualization. Still continuing with visualization. On the next slide, we have the sharp values. The sharp value technique, which are saying is an importance score to each input future, and it's based on cooperative game theory. And for it helps to explain individual predictions, global and local. So with this output, this is the sharp value technique for VT model, like vision transformer model. So with this output, we can observe that the model relied on the distinct patterns and contours to classify the images. And then for it, with this output, we can observe that the brighter regions of the heat map emphasize the guineas themselves, as you can see here, and it indicates that the model relied on their distinct patterns and contours to classify the image. So with the background, as in the cooler tones, we can observe that it played a minimal role in prediction, which shows that the model appropriately focused on the relevant objects to make classification decisions. So that is what we had for you.